So for my weird experience project, I wanted to do flat earth theory because I feel like a lot of people make fun of it, a lot of people don't take it seriously, and considering the people that do actually believe in it take it very seriously, I wanted to learn more about this. I figured it'd be kind of fun and interesting, and it can't harm anything to learn new stuff. I really enjoy learning new things and researching when I have the time. And so I got into it, and the thing is, there's a lot to learn about flat earth. They talk about a lot of different topics, a lot of different ideas, all kinds of different things that are like their evidence-based stuff. So I was kind of looking into, okay, what can I talk about that I can really prove or disprove that doesn't have to do with things such as like NASA or the government, because, yeah, I don't really know how much of that stuff is believable, so I wanted to look into things that I could prove myself. So one of the biggest arguments is that the Earth curves at 8 inches per square mile, and so with this math, one example is that something 5 feet tall would disappear at 7.5 miles. And so I looked up a few YouTube videos looking at different people trying to show whether things do disappear over the horizon or not, because that's one thing that globe earthers say is that, oh, well, you know, things disappear over the horizon, you can't see it anymore, and I was like, okay, but can you see it with a camera? Like, how does that work? And so there was one example where someone zoomed in on Bradford Beach from Sheridan Park at a distance of 7 miles, and at 7 miles you shouldn't see something that is 4 feet 8 inches or underneath. And in the video, you know, he shows you where he is, he zooms in, he zooms out, you kind of get a whole scope of everything, and you can clearly see things that are lower than 4 feet 8 inches. You can see the sand, you can see the ground, you can see cars and their tires and everything. So that was very interesting to me. And then there was other videos that I looked at, and in each example the object is still perfectly visible. So the problem with this theory, though, is that we don't actually know how far that we can see until an object completely disappears from the sight of the eye or the camera. Part of the reason we think it disappears is we can't see it anymore. And so when the camera zooms out, you can clearly see that, okay, when it's zoomed out, you can't see the beach anymore. And same with your eyes, you can't see it anymore because your eyes don't reach that far. And the thing is, we don't have a camera that can see all the way across a flat earth or all the way like around a globe, and so this is a very difficult one to really wrap my head around because it's kind of hard to delve into and prove. But I definitely think it is worth playing with and looking into more. Another testable hypothesis is how the sun reaches like two different objects, such as sticks. So a lot of people will put two sticks on the ground and compare like how the shadow goes. And so one popular globe theory is that, well, if you put two sticks on a flat earth, they have the same shadow no matter what. But if you put them on the globe earth, the sticks will have different shadow lengths and whatnot. But the thing is, the sun and the earth move in different ways depending on which theory you're looking at. So the globe earth and the flat earth have different movements of the sun, which means it's very hard to compare the two because you don't have like one specific variable that doesn't change, which makes it even harder. Like, let's say you use a light bulb and a ball and a light bulb and like a like an actual flat surface. That's not going to be comparable to the sun because the sun is at a different distance, and that's another thing that globe earthers and flat earthers talk about, is how the sun may be at different distances from the earth. So that would change things in even like just the direction of where the sun is. And in doing this research, it's become clear that finding an answer about this with doing your own tests is really difficult. it would definitely be like the best way to do things, because then you could try to prove it on your own and discuss about it and whatnot, but it's very hard to do because of these circumstances that I've discussed. But if these hypotheses that I brought up were more testable and had, you know, a better controlled setting, then it would be a little better, a little easier. However, so the flat Earth hypothesis, I feel, has been proven to be more fruitful because the going over the horizon test results seem to favor more of a flat Earth theory. However, the globe Earth is a little more conservative. We've already like known this, especially in the US. And so it's a little hard to kind of tell like what direction you want to go. But I do believe that doing tests and research on both sides is really important, and that hopefully someday we can kind of come to a conclusion, or at least be able to discuss it more openly in a more friendly way. So yeah, thanks.